Right, great stuff. So this is the high-low method. What we're trying to do here is to find the variable cost. So what we're really saying here is that um, we're working with the assumptions the variable costs per unit are constant and that they do not change as you, they are the same thing with every unit you produce. So we can in effect find what that variable cost is by looking at the movements um, every time we produce a unit. So here I have 15,000. Imagine I have 15,000 units here and I have a total cost. Remember, this is total cost. I have a total cost here of 105. So I have a total cost of 105,500 and I have 15,000 units here. And then I'm ending up at 17,000 units here. 17,000 units here, and I have a total cost up here of 118,500. So what we're saying, it's always based on the units. What we're saying is when we go from 15,000 to 17,000, on average, costs increase. So actually, this is not a very good graph because I need this to come and hit here to hit there's a fixed element, isn't there? Because this is a semi-variable cost. That's the point. This isn't purely variable. There is a semi-variable. So I'll just bring this down a little. I'll just bring this down a little, and then I will erase this. Yeah, something like this, so you can sort of get a better feel of how this works. Right. So what I'm now saying is that when this goes from 15,000 to 17,000, this goes from 105,000. So I'm saying when this increases from 15 to 17, this increases from 105 to this. So the question really is, I'm saying what happens? What is the change in cost when this increases by 1 unit? And if I know what happens when this increases by 2,000 units, I can find out what happens when how much the cost increased by 1 unit. Yes, that's in effect what I'm saying. So therefore, what we're saying is 118,500 minus 105,500 divided by um, divided by 17,000 units minus 15,000 units to get that variable cost, and you will find that you get 118,500 minus 105,500 divided by, so this is 13,000 divided by 2,000, and that is £6.50. Right, so £6.50 is the value of your variable cost. Now, what does that mean? Now that I know what a variable cost is, I can find the fixed cost. I can just pick this one and say, listen, if the variable cost is 15,000, if I'm making 15,000 units and the variable cost is £6.50, so that's 15,000. So my variable costs are 97,500, but my total costs, of course, are here 105,500. Well, I know what my fixed cost is, right? 105,500. My fixed cost is 8,000. So now I know what my fixed costs are. I know what my variable costs are. I can find this information for anything because total cost is equal to fixed cost plus variable cost. If my fixed cost is 8,000, someone says to me, Wayne, what's happening with 16,750 units? Well, I know the variable cost was 16,750 units times £6.50. I can find that out. Yes, 16,750 times £6.50 is 108,875. That's the variable cost, isn't it? So I now add that to the 8,000 and I get a total cost of 116,875. Yes. And so your total answer would be 116,875. So I always recommend just take it step by step. Find the variable cost first, which is all you can do. Then you now take that figure and go and plug it in a figure that has to be, well, technically on the line, because that's this. And the only two figures that we are certain that are on the line are the 15. And remember, this is a kind of rough-handed way of doing this to find this average cost. And then you now take that, find the total variable cost, deduct that from the total cost for that particular activity. Then you can find its fixed cost, and then you can take those two figures and apply in any extrapolation if you're asked. That's the whole point of this. Can we extrapolate and find what total cost would be like for others? Okay. So what we're looking at here is the correlation coefficient. And if you remember, what we were really saying with the correlation coefficient when we calculated it, you will be given the formula if you had to do it, is looking at the relationship between, if you like, typically the independent variable. So the independent, so in this case, is on this axis, you would have the machine hours or units or whatever it is, and that's the cost. Right, and that's typically the case, isn't it? We've always on the whatever's causing it, and then you have the cost, which is dependent. I mean, the more hours, the more cost. So cost is dependent on machines. So this is the dependent variable, right? So we calculate the coefficient correlation because correlation coefficient, sorry, tells us the extent, or sort of says is there any relationship? Just is there any relationship? And if you remember, we said that the closer we noticed the figures, then R was closer to 1, and the further away, or well, or -1, depending on if we were talking about something that looked like this, the closer. So this is -1, and this, of course, here is +1. So you have this scenario here of relationship. That's all this is measuring. Relationship. Is there relationship between, and how close this relationship is between them. But if we actually want to understand, or if we want to push this argument a bit further and say, does the independent variable cause this? So this is the coefficient determination is a measure of causation. It's saying, does this cause this? So what we do is we square this. Now here's the thing. Imagine this was 1 or -1, or this was 1, and you squared it. You literally get 1 again. So we're literally saying that the closer these are to be on the same line, and then the closer it is, that we can argue that whatever is happening on the x-axis, which in this case is really here, we're saying that whatever is happening on the machine house is causing, if you like, the overhead costs. So this is about causation, and that's 0.72. This just tells us that there is some relationship, the extent of the relationship between, but it doesn't say that it is caused by. And you see, this question is really all about causation. That's why they've used the word explained, explain. And for that, we need to look at the coefficient of determination. Okay, great stuff. And so we're saying there's a 72% chance. There's a 72% chance that the overhead costs are caused, if you like, that the variance percentage is caused by the overhead costs and by the machine hours. Okay, great. So to do this, you definitely need to have watched the video and the theory on learning curves in general. But the theory is pretty straight. It is saying, listen, as you double the number of units that you make, the time it takes to make an average unit falls by a fixed percentage, by a set percentage. So what does that mean? So it says, listen, when you make the first unit, in this case, it takes a total of 18 minutes. That's the total. You can put total, and that's the units. Those are the units. And so the average, of course, must be 18. Yes. So the question then says that the time it takes to make the next 15 units is 73.2 minutes. So hopefully you can see the link here with doubling. Because if you look at the double, what we're saying here is that this goes 1, 2, 4, 8, 16. That's what we mean by double. Every time we double the number of units, this average time falls by a certain percentage. So we can find the average time in effect. But so what you have is you now have the time it takes to make the next 15 units, right? So which means in a way you can know what the total time is for 16 units, because if it takes this to make 15 and it takes this to make the first, well, I can tell you the total time to make 16 units would be 73.2 plus 18. Yes? So 73.2 plus 18 is 91.2 minutes. So if I now know that this is the total time it takes to make 16 units, I can find the average time it takes to make 16 units. Well, the average time it takes to make each unit, if you like, here, but just the average time. So the average time, in effect, is now 91.2 divided by 16, which leaves us at 5.7, right? 5.7. So the task now is, okay, well, look, I'm saying that when you double this, this falls by a fixed percentage. So this falls to a lower number because we're getting better. So I'm just going to call that y. So this becomes 18y, right? I mean, this percentage. Imagine this y is less than 1. Imagine this was 95%. I'm saying that the average time it takes to make 2 units is now 18 times 0.95, which is, I don't know, whatever, 17. It's taking less time on average. And I'm saying it's the same thing. It falls by exactly the same every time. So when I make 4, when this doubles again, I'm basically multiplying this again by y. Again, I'm saying this thing times y. It falls again by the same. And when I do this one, I'm saying this is again the same thing times y, which means by the time I double this again, this is equal to 18y raised to the power of 4, right? Because I've got the y 4 times by the time I'm here, because that's what this answer is. So I'm now in effect saying that 5.7 is equal to 18y raised to the power of 4, which means that I can find y by simply saying that, well, y4 must be 5.7 over 18. And 5.7 divided by 18 is equal to 0.31666, or whatever, recurring. So I need to find y. So I need to find the fourth root. Yes, I need to almost find, because this is y raised to the power of 4. So I need to basically go into your calculator and find what is the fourth root. Y4 is equal to 0.31666. It's like saying this. Imagine this was, if I asked you y4 is equal to 16. What is y? Well, we know that y is 2 times 2 times 2 times 2. So I'm basically saying, how do I find y? How do I find y if I know that if I raise it 4 times, I get 16? So what you do is you go to your calculator and you find 16 to the fourth root. Find the fourth root of it. Yeah. So what we need to do is to find the fourth root of this 0.316. I'll go to my calculator here and I'm going to put in 0.3166666666666. I'll go for a while, and then I'm going to raise this up. Well, just however your calculator, make sure you do this so that I'm just using one method. I'm going to find, because I'm using a computer calculator, so I'm going to raise this up to the fourth root, or I'll do it both ways and see what happens. So here you have, you get 0.75, which means that your y is 75%, if you like. Let me try another one and see if my calculator will do this one. 0.316666666. If I can find, I think sometimes I need to do the second degree. Will it let me do that? Second degree. Oh, here it is. Yes. Here it is. Y root 4. And then that should also take you there straight away, 0.75. So basically, look at your calculator, because you see what I had to do was to kind of go into if you press the you have to get used to your calculator, do that. You see other things appear. So this is giving you the root, here. So you can do it. But again, just play with your calculator and arrive at there. We're going to always look at this at revision again. Okay, great stuff. So this is a good question for revising outturn methods and contingency values. So let's understand what's really happening here. So we're told that, listen, this budget in front of you, the 1st of April 17 to 31st of March, was set. Again, let's just draw a timeline. Was set, if you like, in November 2016, because that's how it works. The future, if you like, of 17-18 is set in 16. So we're now at the end. We've done that. So these figures worked through this period, right? That's what we used. But now we're coming to set the budget for the 1st of April 18 to the 31st of March 19. And what would have happened was we would have met in November 17 to set this budget. That's the point. So we want to set this budget. And remember, with the normal standard method, we just ask what's happened in the year. And then whatever new events have happened in the year, we adjust the existing budget that's currently happening. So we're here November 17, and we now know that what actually happened was people received a pay rise on the 1st of April right, in the 1st of April. So we will now adjust this budget with that. We will simply say, well, look, when we now plan the budget for this period, if we're using this standard fixed method, we simply will multiply this by the 1.05. Sorry, admin staff. So let's just get this right. So my admin staff, I'm increasing that by 1.05, and my teachers are increasing by 1.07 because I have this happens on the 7th of, I'm sorry, on the 1st of November. So that happens somewhere there on the 1st of November before our meeting. So we know about these two events. So we will now apply these events to our budget when planning our budget. So what is that? So the 240,000 times 1.07 takes us to 256,800, and the admin budget increase by 5% takes us to 63,000. So from a fixed point of view, this is our budget, right? This is our standard budget. Now, the question goes on to say, well, what if we want to as well include what we know about that could happen in the future? Remember, when we meet at 17, we only take events that have happened. So when we do this here, what we are saying is that in the future, because it's going to happen, we're planning for this budget, we know that you will also be giving a 3% pay award. So if you wanted to do that, that's the outturn method, yeah, if you want to go with that. So we should also include that possibility. So this 3% that's being applied to admin staff is sort of saying, listen, we would also be, increasing this by 3%. So that is the addition. That's what this question is really asking. This question is really asking, well, what is that 3%? And so that 3%, if you look at it, is 1,890. Because the new budget, technically, if you do the new budget, it'll be 63,000 times 1.03. Yes, so basically take the 3% and add that onto the 63,000, which technically would have been 64, 8,890. This would have been the budget under the outturn method, but we're just talking about the change. That's all we're interested in. Here, we're interested in the change that's where we see an increase in 4%, but not until the 1st of November. So I would demand the best thing to do is to find the 4%. And when you find the 4%, you need, so find 4% of the 256,800. And then you need November, December, January, February, March. You need 5 months of when it will happen. So multiply that by 5 over 12. So let's do that. So 4% of 256,800 is 10272, and then multiply that by 5 over 12, and that takes you to 4280. So these are the two changes, the 4280 and the 1890, which will take us to a total 4280 plus 1890 takes us to 61. Excuse me, 6170. Excuse me there, 61. So that's your change, 6170 for that answer. Cool, great stuff. So if you look at this question, let's work through this. We are given, you're actually given the formula. I'll write this out and then take you to the formula. If you look on the, if you look at the question, we would have seen something like the sum of x minus b, the sum of y divided by n. Yes, that's the formula for finding a, right? So the sum of x, the sum of y, forgive me, minus b times the sum of x. Yes. So the sum of y, which is this, and you should expand this, of course. So this is 5630, of course, because this is 5.63. This is thousands, right? 5.63 times 1,000. Yes. 1, 2, 3. So 5630 minus b, and b, of course, is 1.21 times, if you like, x, which is 2550, as in the sum of x, divided by n, which is the number of events, and that's 4. And so that's pretty much that. And when you write all this out, you get a sum of 636. So you have a fixed cost of 636, and that's your answer for that. So again, this is now using formulas to calculate, if you like, fixed costs and total costs. We sort of did earlier questions, didn't we, on the high-low method? But this is using a formula to actually find out what that A is, what that A figure is, and that's what we've just found. Cool, great stuff. Here they're asking us to find the correlation coefficient. I talked about that. This seeks to find out, is there any relationship, or what is the relationship between, if you like, the x and the y figures. So we're just literally plugging in these figures, aren't we? So we are given n. We're told that n is equal to 5. So we are literally saying, well, what is 5 times, well, what is the sum of xy, and that's given to you here, times 2927. So you have that. And you say minus, well, the sum of x, which is 83, times the sum of y, which is 174. And you divide all of this by the square root of, again, we have 5 times the sum of x squared, which is 1395, yes, minus, just take the x itself and square it, so 83 squared, right? So do all of that, and then also, then on this as well, do 5 times the 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 y squared, yes, so the sum of y squared, which is 6142, and then subtract just the y squared on its own, 174 squared. So we literally need to plug all of this into a calculator and see what we come out with. Was this so I can just do this, all because of time saving, just do the actual calculations myself, first of all. So there you have 14635 minus 1442. So if we just do this top bit here, we should have something that looks like this. 14635 minus 14442, which is 193. We have 193 on the top, and on the bottom we should have the square root of 6975 minus 6889, which is 86, times, of course, the square root of 30710 minus 30276, which is 434. This step by step, so that you can get there. You could put all this in your calculator at once if you know how to. But if you look at the square root of 86, that's 9.27. The square root of 434, that's 20.83. So multiply those two together. Well, if you want, you get 9.27. I hope I'm not too far out with my 9.27 times 20.83 is, I have here, this comes to a total of 193.0941. So in effect, I have 193 divided by 193.0941. Let's see what that looks like. 193 divided by 193.0941. I have 0.999. So this is good. So I mean, there's no risk that I was worried that it might be, but this is a strong 999. So that's your answer. So it just takes a bit of a long time to do, but it's good. Well, you get the 2 marks, so you're safe. Cool, great stuff. Let's look at this question. What's the story? What's the story here? Oops, actually, I need to snippet this out. Let me just quickly snippet that out. So snippet this out, so I can write on it. I'll just take that bit there. And we have this. Okay, great stuff. So what do we have? We have we're doing a zero-based budget, right? So we're ignoring this. It's not incremental. So we're not doing anything based on last year. So purely based on setting up this budget from scratch, it says we have 100 spaces, but 20 of those spaces are going to go on annual permits. So they'll be, think of it as people who we normal people, when I say normal people, not everyone can go in and park there. So people have bought those spaces in effect. And that's what's happening there. So £200 they'll pay for them, 20 of those seats. So we're expecting, if you like, £4,000 from that standard. Okay, great stuff. Now you have 80 spaces, and what will happen with these 80 spaces? So you have two things happening. You're going to sell them at £5, no difference, that's fine. But you will sell them um, for 250 of your working days, and then you'll have another 115 non-working days, right? So £5 every day, but 250 days, but only at, at the 90% sort of expected capacity or occupancy of that. And the other days will be quieter, 20%, right? So that's kind of what we're working with here. So in effect, we just need to work these figures out. So we here's my calculator. So we have here 80 times is 80 spaces times 5 times 250 times 0.9 takes us to 90,000. We have 90,000 here. And then we have 80 times 5 times 115 at 20% takes us to 9,200. So 9,200. So these are our three figures to work with. Add all these together. 9,200 plus 4,000 is 103,200. 103,200. So that's your budget for the next year using zero-based budgeting. Cool. Here we are looking at a future contract in effect, or a future budget in effect. So I mean, these are the figures that we would have had at the fixed sort of method, right? Would have built our budget, and they're telling us in effect to adjust for these changes. So at 15,000, if you're having a 6% increase, well, this is of course per annum, of course. So let's first of all just find what these figures are. 20,000 times 9%. So this takes us to 6% here takes us to 900, and this takes us to 1,800. I'll just change my pen color. Now this is from the 1st of July. So 1st of July is if you like, it's April, May, June, and then July we're going up. So 9 months. So we have 9 months of this budget that will go in. Here, 1st of October, April, May, June, July, August, September, and then going forward. So we have 6 months of this budget that will be going through, that we'll add in. So 9/12 of 9/12 of 900 is 675, and this of course is 900. So we will be topping up these budgets with these changes, won't we? It's 20,000. So in effect, this is currently 35,000. Yes, add those two together, 35,000, and add on these new additions. Add on these new additions, and you will get 36,570. I believe, yes, let's just do that. 35,000 plus 675 plus 900 is 36,575. Cool, and that's that question. Okay, and the final question in this quiz, I think, is this one that can be done in a number of ways. I think from the way I wanted to do this, it just felt a little bit clearer for me if I sort of, this is the total of all the stuff. If I just took this away at the beginning of the year, I just felt a bit more comfortable dealing with this senior consultant separately. So I sort of said, well, here is what it is for everybody. 111. Here it is what it is for everybody. 115,000, and I sort of just decided to just take away this person first of all and find out what the normal staff, what their budget was. So that was 102000, and I then said, okay, listen, what is it? What are we going to be giving this senior consultant for the time they're with us? And of course, that's just the 95,000. They're with us for just 2 months. So I said, let's just find that. I just felt a bit more comfortable finding that. And I did that, and you will get 15,833. So I was like, okay, 15,833. That's sort of that. Now, yeah, I think that's kind of the main point. And then you work with this. Then we now know that this is going to increase by the 2%, right? Then that's what's happening there, right? I think there's two ways to have done to I think to think about this. It tells you the question that this 2% has not it will be applied. So this figure of 85 was at the initial sort of pay grade. When by the time we implement all the new sort of directives, this pay grade is going to be upgraded as well by 2%, is what we're saying. This person coming in will also get this pay grade increase of 2%. Just this is what the standard official documents are saying, but when they come in, everything's going to be upgraded. So they're going to be getting 85,000 times 1.02 anyway. So I just thought it was better looking at it like that. So they were going to get the full year if they start with us would be 86,700, but they're not going to be with us for the full year. They're only going to be with us for 9 months of the year, right? Because they turn up in July. So that takes us to 65,025. Like I say, there's a number of ways of thinking about this. So now we know what these are. So we can just find what this is. So this is the 1020. Just calculating this over here, right? This bit here, 1020 plus 15833 times the 1.02 takes us to 105,655. I'll just round up. So this is from the existing people. So these are the people who were always with us. They get the 2%. This is the amount of the person who's with us for the period of time. They will get 2% on that little amount they're with us for. And then you add those two together and you get 65,025, and you have 1121575 if you want to approximate it, and it's over there, right? And that's kind of how you work that. I suppose you could have left the 85,000 in here as well and just multiplied. I think that might have been tricky. Sorry, the 85,000 times 9 over 12, and then multiply that by 1.02 as well to show the increase. Yes, let's just multiply 85 times 9 divided by 12, 63,750. So this is equal to 63,750. So if you add all these three together and multiply by 1.02, you will also get the answer. So I think it's just depending on how you shape it or how you look through it. Cool, great stuff. And that is the end of unit or quiz 5.